In this video, we're going to be continuing our notes on triangle inequalities. We left off just before this part called the SAS inequality theorem, which is also called the hinge theorem. And the entire page here kind of explains it. But, these two triangles would be congruent by side, angle, side, because their corresponding sides, included angle, and the other side would be congruent. But what if the sides were still the same, but what if this angle was opened wider? Okay, what that tells us then is that where the angle is opened wider, the side across from that would be greater than the side across from the angle in which it was not opened wider, if that makes sense. And that's why it's called a hinge theorem, because you think of it as a door. If I open the door wider, the fingertips get further apart. And so as long as the sides are the same length, but one angle is bigger than the other angle, the side across from the larger angle will be longer than the side across from the smaller angle. It's kind of a basic thought. Let's see if we can apply it. Here it is in its formality. The SAS inequality theorem, also known as the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, but the included angle of one triangle has a greater measure than the included angle of the other triangle, then the third side of the first triangle is longer than the third side of the second triangle. It's a mouthful, but hopefully you were able to follow it. If not, listen to it again. So here we're supposed to list the sides in order from least to greatest. And I see that I have two triangles with a shared side. And what I'm going to do is break this down into those two triangles. And I'm going to first figure out what is the shortest side in triangle 1. From least to greatest, we do shortest, then the next one, then the longest side. And then we're going to do the exact same thing for the second triangle. So let's see here. Triangle 1. Remember, we can use the angle measures to determine not necessarily the exact length of a side, but its rank. We can figure out which one is the longest versus which one is the shortest. And I have two angle measures in triangle CBD, but I can figure out the third measure if we use the fact that the three angles need to add up to 180 degrees. So let's do that. We'll do that a little bit more informally. 45 plus 92, that's 137. And then 180 minus 137 is 43. So this one has a measure of 43 degrees. So in triangle 1, we have these three angles: 43 degrees, 45 degrees, and 92 degrees. And I put those in order from smallest angle to largest angle, which means the sides across from those angles will be in the right order, least or shortest to longest. So if we look at 43, what is across from that? That is side BD. Across from 45 is side CD. And then across from the 92 is BC. So in triangle 1, we have them in the right order. Okay, but just because BC is the longest in triangle 1 does not mean that it's the longest in this entire diagram. So we need to do the same thing for triangle 2, and then we'll find a way to compare those two sets of sides. Triangle 2, I have 57 and 68. We can use those to find the measure of the third. It looks like we're getting 56. So my three angles for triangle 2 is going to be in order from smallest angle to largest angle: 56, 57, and 68. Now, that means the side across from 56 will be the smallest in triangle 2. Across from 56 is CE. Across from 57 is CD. Across from 68 is DE. All right. Now, in this diagram, 92 is the largest angle. And it's possible that BC, because it's across from the 92, is the longest side in the entire diagram. But we don't know that just based on the fact that 92 was the largest number in the diagram, or the largest angle in the diagram. Because all that tells us is that BC is large compared to the other two angles in that triangle. Luckily, we have this shared side. We have this shared side of the two triangles, which allows me to make a comparison. So we know that CD in triangle 1 is the same as CD in triangle 2. We actually also have these hash marks here. That tells me that BD and CE are the same length. So we really don't have that many different lengths here. And we do know that those two are the shortest ones. So we're going to write that out first. We're going to put that BD is, BD and CE are equal to each other. And they're going to be first because they're the shortest. After BD is CD. And so we know that that one's next. And now the question is, what about BC or DE? What about BC or DE? They're from different triangles. And some of you are probably like, we can just tell by looking. We're not allowed to do that. So this is where we're going to apply the hinge theorem. You see, we notice that this side is the same as this side. This side is reflexively the same. But we can look at their included angle. For triangle 1, that angle is 92. For triangle 2, that angle is 68. So because 92 is bigger than 68, that means that BC is bigger than DE. And so now we have the order. That's the answer. I'm in a Google Meet right now, so that's why my computer is going so slow. I wish it wasn't. So now we move forward to the SSS inequality theorem. It says if two sides of a triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is greater in measure than the included angle of the second triangle. That is definitely a lot to say, but I'm going to draw it out a little bit. We have let's say that this side is the same as this one. These two are the same, but I'm telling you that this is 7 units long and that this one is 8 units long. Then that means that this angle is bigger than this angle. Okay? That's what the SSS inequality says. It's really the converse of what we just learned about the hinge theorem. So now we're going to take that and try to apply it here. In the diagram, they told me that segment XM is a median. So from X to M is a median. If you recall, we draw a median from the vertex to the midpoint, which tells me that these are the same. And for these two triangles, that means they have two sides that are the same. We are told that XY is greater than XZ. So the length of XY is greater than XZ. What can we say about the measure of angle 1 and the measure of angle 2? Well, the measure of angle 1 is greater than the measure of angle 2 because the application of SSS inequality theorem. Okay, so what we're saying is the two of the S's are the same, but the third S is unequal. That's where the inequality part comes. And therefore the angle that is across from that, one angle has to be smaller than the other one. And because this one's longer, this one's larger. This one's shorter, so this one's smaller. That is the inequality theorem, SSS inequality theorem. Okay, so we're back to doing another diagram where we have a couple triangles. We're going to list the sides in order from least to greatest. And I again suggest, let's try this one triangle at a time. So triangle 1, let's get the angles in there. It looks like we have 44, we have 81, that's a total of 125. And then if we subtract, we get 55 as the third one here. So from least to greatest in triangle 1, these are the angles: 44 degrees, 55 degrees, and 81 degrees. The side across from 44 degrees will be the shortest side. That is side XZ. Across from 55 is WZ. and then across from 81 is WX. Now, you see the 102, that is definitely the largest angle in this entire diagram. But that doesn't mean that whatever is across from the 102 is the largest side in the diagram. It's just going to mean that it's the largest side in that triangle. And that's important to understand. I may be the best teacher in your geometry classroom, but I'm not the best teacher in the world. So let's do the same thing for triangle 2. We have 36, 102. We add those together, we get 138. To subtract that, or if we subtract that from 180, we'll find the measure of the third angle. That is 42 degrees. So 42. Okay, so in order from smallest to largest angles in triangle XYZ, be 36, 42, and then 102. So now the side lengths across from 36 would be the shortest in triangle 2, which is ZY. The shortest in, or the one across from 42 is XY. And then the largest in triangle 2 will be across from the 102, which is XZ. Now we do have a shared side, and that's how we're going to know overall how these compare. You know, XZ is the largest side in triangle 2, but in triangle 1, XZ is the smallest. So what does that say about XY? How does XY compare to WZ? We know XY is smaller than XZ, and we know XZ is technically smaller than WZ, so XY must be smaller than WZ, which means these two are the shortest two sides. So the sides from least to greatest is ZY, that's the shortest side in the entire diagram, XY, XZ, WZ, and the largest overall is WX. And again, the only way we would be able to determine that is because we had the shared side. We had something that we could compare to. Otherwise, I wouldn't know about WX compared to these others. Okay, in this diagram it says, below is isosceles triangle ABC. List everything you can about the triangle and why. I have given you an outline here because there's a lot to write. I'd rather us just fill in some blanks here. I know that blank is true because 61 is greater than 49. You see, we have this side is marked as the same as this, and then that's a shared side. But because 61 is greater than 49, what is it that's true? Hopefully you realize it's that DC is greater than AD. Triangle ABC is a blank triangle, so is an isosceles triangle. So they already told me that AB is congruent to BC. What else did we learn about isosceles triangles when the two sides are the same? It's that the base angles will also be congruent. So angle A is congruent to angle C. Those are the base angles. Since the vertex angle of triangle ABC, that's this guy, is blank, I found that measure of angle A equals blank and the measure of angle C equals blank. So we can actually figure out those measures. Since the vertex angle is, well, the total is 49 and 61. My brain wasn't working there, but 110. Since that's 110, I found that the measure of angle A, remember these are supposed to be the same. There's 70 degrees left over in this triangle. You divide that by 2, you'll get 35. Lastly, I can find the measure of angle ADB and the measure of angle CDB. So this is 35, this is 35. And if we use triangle sums, we can figure out the measure of our final angle here in this triangle by taking 49 plus 35 and then subtracting that from 180. And you would get 96 degrees for ADB. And then CDB would be its supplement, and that's going to be 84. 84 degrees. I'm just using the fact that those are a linear pair and would be supplementary. So yeah, there's a lot of information that you can figure out, even though they didn't give us a whole lot of information to start. So there you go. Let's recap this a little bit. Something from the beginning of the lesson. List the sides in order from shortest to longest. In order to do that, you need to know the angle measures. We know 2 of them. Let's find the third one. And then subtract that from 180. We'll get 35. Now that I have that, I can list them from the angles from smallest to largest first. 35, 62, 83. And then directly below that, we'll put the side that goes across from each of those. Across from the 35 is AB. That's the shortest side in this triangle. Then across from 62 is side BC. And then across from 83 is AC. Over here, we're going to do the exact same thing, just some different numbers. 44 and 47 is 91. 180 minus 91 is 89. So this is an 89 degree angle. I'm going to list the angles first in order from shortest to longest. 44, 47, 89. And then I'm going to find the sides across from them. 44, across from that is BC. Across from 47 is AB. And across from 89 is AC, the largest there. And then these last, well, I guess I shouldn't say last, as we have one more slide to go through. List the angles in order from smallest to largest. These are simpler than the previous ones because we already have all 3 sides. You simply find the smallest side, 5, then 8, then 11. Go across, that's the smallest angle then. So angle A angle A, angle C, and then lastly angle B. And then over here, same thing. 15 is the shortest side, then 16, then 20. So 15 is across from angle A, 16 is across from angle B, and 20 is across from angle C. So C must be the largest angle because 20 is the longest side. Okay, a couple things with finding the range here. Determine if these three lengths will be able to form a triangle. Remember, we take the two smaller ones, which would be 6 and 8. 6 plus 8 is 14. And then you determine, is 14 greater than 13? Can it span that gap? And the answer is yes. And then two smaller ones here would be 5 and 7. We add those together, we get 12. Is 12 greater than 14? The answer to that is no. And we have two side lengths, 9 and 3. We are asked, what's the possibility, what's the range of the third side? And the quick way to do that was to take the two numbers, subtract them, take the two numbers, add them. You'll get two different answers. And your number, the third side, will be between that. So it's got to be less than 12, but it's got to be greater than 6. The third side must be between 6 and 12 units long. Okay, and that wraps it up. If you have any questions, please let me know.